Hi, I'm 승현. James Webb Space Telescope. Have you ever seen a telescope before? Telescopes are used to observe various things in the world, and I want to see my love, the universe, with a telescope. Today, I'm going to introduce the James Webb Space Telescope, the newest space telescope. I will tell about James Webb's characteristics, the range of observation, and where the telescope is located. First of all, I will tell about the James Webb's characteristics. But before that, what is a space telescope? It is a telescope that is installed in outer space to observe the universe. Representatively, there is the Hubble Space Telescope, which was launched in 1990. It found the age of the universe and the existence of black holes and more. It made a huge contribution to space observation. Unfortunately, now this telescope is too old that we can no longer use it. So we needed a new space telescope for the next generation. That's why the James Webb Space Telescope was made. NASA spent $10 billion and 25 years to make James Webb. A telescope's sensitivity, or how much detail it can see, is directly related to the size of the mirror that collects light. James Webb can observe galaxies and stars that are very distant, at over 13 billion light years away from us. To see such far off and faint objects, the telescope needs a large mirror. Compared to the Hubble, Webb's mirror is larger, stronger, and lighter. As you can see in the picture, Hubble had only one mirror, but James Webb has 18 mirrors. It is made of beryllium, which is both strong and light. So James Webb is 4.5 tons lighter than Hubble. Additionally, beryllium is good for holding its shape across a range of temperatures. James Webb's mirrors are covered in a very thin layer of gold, which optimizes them for reflecting the infrared light. The biggest difference with Hubble is the range of observation. James Webb will observe the infrared light mainly. But why does NASA want to observe the infrared light? To understand that, you should know about the nature of light. A movement of the observer and the wave source changes the frequency of the wave. We call this the Doppler effect. This is the nature of all kinds of waves. Light is also a kind of wave, so the light shows the Doppler effect too. When the light goes through a prism, it disperses into many colors. Because it is combined with lights of various wavelengths, the word spectrum means the range of dispersed light. When the frequency is high and the wavelength is short, the wave looks blue. And when the frequency is low and the wavelength is long, the wave looks red. Let's say there's a star that's getting farther away from us. The light from the star is the wave, and the wave source is the star. When the wave source gets farther, the frequency decreases because of the Doppler effect that I explained. When the frequency is low, the wave looks red, so the star will look red. We name this effect the redshift. Let's get back to the topic and let's find out why the James Webb Space Telescope was designed to observe the infrared light. The universe is expanding rapidly, so the very distant galaxies and stars are getting further away very fast. Therefore, the lights show the redshift effect. A light of a long wavelength belongs to the infrared area. That's why we should observe the infrared light to find out about deep space. But the problem is that infrared lights are emitted from the body of the telescope itself. It disturbs the observation. To solve the problem, the telescope cooled down to minus 233 degrees Celsius after it was deployed in space. This is because when the temperature of the object is close to absolute zero, it doesn't emit the infrared light. Then the sun and Earth's lights should have been blocked, so the telescope was deployed at Lagrange point. The Lagrange points are where the sun and Earth's gravity influence are the same. James Webb is the second point, L2. James Webb will orbit around the sun with the Earth. It is the best point to observe the universe. And James Webb has propulsion that maintains its orbit, but it will work only for about 10 years. When the propulsion stops working, the telescope will be out of orbit. It means it is the mission to observe various things for a short period. James Webb will start its scientific operations after 6 months later. If the research goes smoothly, we will find out more about the birth of galaxies and the evolution of stars and more. It is the key to solving the questions that humans have ever had. I hope that James Webb uncovers the dark energy. If so, we can find out more about the Cepheid variable and the accelerating expansion of the universe. What about you? What do you want James Webb to find out? It is surprising, just thinking about it makes my heart race. I hope that you also feel the same way. Thank you.